Hey there, Spacers. Welcome back to another episode of the Space Revolution. My name is Rick Tumlinson, and you are listening to iRock Space Radio. We are part of the iHeart Radio Network. Tonight, we have a great guest. His name is Dr. Chance Glenn. He's the founder of the Morning Bird Foundation and its chairman of the board of directors. He's also a tenured professor of electrical engineering and the provost and vice president of academic affairs at the University of Houston, Victoria. Dr. Glenn holds a degree in electrical engineering from the University of Maryland, a master's PhD from electrical engineering in Johns Hopkins, and he also, just because that wasn't enough, he went ahead and got a management development certificate from Harvard. Now, Dr. Glenn is an expert in many things. He's a Renaissance guy, and we're going to have a Renaissance conversation. We're going to meander all over the place. And you've heard me have these kinds of conversations before, but I think it's important that we understand that those of us, the nerds and geeks of us out there, who may not be able to focus in and say, hey, we've got attention deficit, or we have all kinds of interests, or we are wanting to create here, here, and here. There's a role for us. It's called leadership. And Dr. Glenn manifests that. Welcome, and thank you for coming to the show.
Wow. Well, you built me up quite a bit, so I have to deliver. Thanks for having me on, Rick. It was great when I met you the first time, and look forward to having this conversation with you.
Yeah, well, look, I should say the first time we did meet was last year. We had you in for the New Worlds Conference and the Space Cowboy Ball, where one Gwen Shotwell, who won the Space Cowgirl Award and is the CEO of a little company called SpaceX, presented you with the Permission to Dream Award. And we gave you that award because you are such a leader. An inspirer. And we're going to come back to talking about that leadership and that inspiration here in a minute. But I just want to nerd out to start. I want to talk about faster than light and time warp travel and this stuff you're working on because it blew my mind. We had you and a couple of your compatriots do a session at the event. We got a lot of good feedback on that, which ranged from what the hell are they talking about to, oh my God, this is real. So help us understand. We're talking about what you see on Star Trek, what you see on shows like that. Often, obviously, it's Hollywood, so they warp it, all puns intended. Tell us about it. What is it you're working on?
Interestingly enough, Star Trek, they employed a lot of technical advisors, many of which were with NASA at the time. So a lot of the things that they talked about had some basis in reality, and if not so much actual, science fact. But I've always been enamored with Star Trek. Even some of the other technology I've developed is related to that. I did a show one time talking about 10 technologies inspired by Star Trek, and one of them is warp drive. Now, obviously, a lot of people are thinking about this stuff, but it goes back to, you start with, Einstein's general relativity and the whole notion that gravity itself is not a force, but instead it is a consequence of us living in curved space time, and very massive objects or even highly energetic objects have the potential to bend space time, and therefore we fall into that object. And that's what gravity is. They've proven this now that, Einstein just basically had a thought experiment, which he often did, and, really formulated all of these ideas from it. But they've proven it now through some of the measurements out in astronomy, like with light bending around very massive objects. So that tells us that it is possible to do so. So then comes along a guy named Miguel Alcubierre, who wrote out a mathematical metric, it's called, and a metric is just basically a measure of space and time and where you are. he developed a metric that said if you could bend space-time in this manner, then you could propel yourself at enormous speeds. And he not only that solved what the energy density requirements would be, and what would actually happen to space-time, as it were. Then another gentleman who's a good friend of mine now is Sonny White came along
Mm-hmm.
and said, here are some ways to reduce the energy density requirements down from the combined energy in the entire universe to something manageable. And he did that. Here's a key problem. Key problem was the energy density requirement called for a negative energy. Now, I know you've been around a lot of people who protrude negative energy, but that's obvious. We can't tap that. No one really knows what negative energy was. So many people are chasing different ideas, some being dark matter or exotic matter, and even Dr. White is looking at Casimir effect at a quantum level. So there's a lot of different ways. Now, here's my contribution to all of this. The energy density requirement has an equation that essentially says the function that you use to shape the space-time, there's a square of that term, and then there's a big negative sign in the front. Okay, well, I'm an electrical engineer by background, and I understand about complex numbers that under the right conditions, you square a imaginary number and you get a negative number. And then when you multiply a negative number times a negative number, you get a positive number. So if you can introduce this complex variable into this equation, then you could make the energy requirement positive. And that's what I did mathematically and did simulations mathematically to show it. The next step was, okay, how could you actually realize this? Well, again, I'm a RF engineer, which means, radio frequency, high frequency electromagnetics. I looked at this and said, well, there are dielectric materials out there that have interesting properties, and some of which have complex numbers to their dielectric constant. They're called lossy materials. And so I started looking at that, and lo and behold, I found a material that operates at the frequency of interest that I was looking at and has the property needed to do it. So the question is, why does it require a complex material in order to do this, to turn this negative energy requirement positive? So one side thing I did, I started investigating where did complex numbers come from. And before we were using symbols for mathematics, centuries ago, mathematics was done more by geometry. So a square would actually be a square. And if you said two squares, 2x squared would be two squares put together. Okay? And that's how they did mathematics. The problem was, there's a whole interesting thing going on that, let me just throw this in.
Okay.
Back in the day, mathematicians used to compete for positions in universities. And the way they would compete was that I would come to you and say, here is a problem. If you can't solve this, then I can take your job. And you would vice versa have such a thing, right? And that's how people kept their jobs or competed for jobs. So it would actually behoove you to have a unsolvable problem in your back pocket, right, just in case somebody came along to take you out. And he said, aha, solve this. Well, this cubic problem was this is like x to the third power solution, was something nobody could solve. And this guy, and I don't recall his name at the time, he solved it and had it in his back pocket. And it sat there for centuries because, well, I shouldn't say centuries, decades, because his student eventually unleashed it. But the important solution there was the creation of a complex number to try to determine how to solve for a negative space. That's what. Now, I didn't know this before I embarked on my approach to the solution. I learned this afterwards. But I find it interesting that a problem that required a complex number to solve a negative space is now could be used to solve a requirement for negative energy now. And it kind of all fits together. So let me just sum up.
Mm-hmm.
The complex number value in the shaping function is necessary to have a solution for the energy density that is positive and therefore actually realizable. So now the next step was to go to an experiment. And I'm sitting in my lab now. As a matter of fact, right over there, I'm pointing. You probably can't see it if it's just audio, but over behind me, there's a setup that I'm working on that would help me to measure to see if I can actually distort space-time with this particular approach. And I can talk about the measurement technique, which is something that has just kind of hit the news recently, if you like. But I
sure.
I could take a breath here.
Yeah. So obviously you're excited by it, and you should be. So for those of us listening who maybe aren't as mathematically inclined or in physics, by the way, you're saying this, and I'm remembering that. What was that Matt Damon movie where they have the equation, and and he's like the janitor, and he walks over and he goes, "Oh,
yeah,"
he fills it in, right? And
beautiful. Yeah, not Beautiful Mind, but
maybe that was I don't know what it was something like that, one of those kind of movies, right? But the point was, because he didn't know what he didn't know, right, and he was inclined that way in terms of being able to put these numbers together. He created a solution, and although you have a vast basis of knowledge, you're approaching this field where people are struggling with these equations, and you're kind of rolling in and going, well, why not try this?
Yeah.
Right.
That's right.
And so that's part one, just to sort of decodify what you just said. So part one is these people have all these fancy equations, and what you may not realize, my spacer friends, those of you who are kind of a little bit outside the field, is everything we do in engineering and physics and these fields can be boiled down to mathematical equations. And has to be. And it's it's like, hey, if we take these two molecules which produce this kind of energy, and we blend them over here with these molecules, and we add this, and according to my mathematical equations, we're going to get something positive out of it. And so that's why Dr. Glenn has just been talking about all of these equations, is that they are the written intellectual manifestations of the physical world.
Yes.
And if you can control those written manifestations of the physical world, then the next step, which is what we're about to go into when we come back from the break, is you're taking these numbers that say, hey, this should happen if we do this according to the numbers. Now let's go see.
Yes.
And that's where we are, right? So we're going to take a break. You are listening to iRock Space Radio. My name is Rick Tumlinson. We're on the iHeartRadio network, and our guest is the brilliant Dr. Chance Glenn. We'll be right back. All right, Spacers, we are back with the Space Revolution. My name is Rick Tumlinson. You are listening to the iRock Space Radio station, part of the iHeartRadio network. And our guest is Dr. Chance Glenn. Now, Dr. Glenn and I were having a very interesting discussion, or actually, he was explaining and I was trying to follow a very complicated conversation about mathematical equations that have to do with enabling the possibility of being able to utilize, manipulate, or interact with what we would call space time,
Hmm.
and the ability to, in a sense, and it's in a sense, be able to have faster than light travel.
Yeah.
All right. So we've talked about the equations. You've
Hmm.
got us all the way through all of that.
Well, let me say something about just mathematics, just
Yes,
briefly,
of course. Yeah,
because
dive in.
you alluded to this. Um, I teach it every now and then, and one thing I tell my students is that mathematics is a language, and what
Mm.
we're doing when we learn it is learning the syntax, and we're learning how to apply it to the situation. Why? Because it's a universal language that allows us to communicate certain truths consistently with others, and to be able to repeat those things, because that's part of the scientific method is to be repeatable. So mathematics is just such a language. Now, as you know, with any language, there's better ways to communicate ideas than others, because it all is about ideas and our
Mm-hmm.
interpretation of reality and everything. And so we write equations to. We've been living for hundreds of years off the notion that gravity was a force. F equals ma and all that. Well, it's not really a force. It's a consequence of a geometry, and the mathematics was finally developed, and now we speak from those mathematics, and that's the language part of all of this. But once you're there, you go from mathematics, and at least my process, I go to simulation next, and say, all
Okay.
right, I so write out the mathematics. You then model it to see, like in things like MATLAB. I take these equations, I run them through, I see what it looks like, and I've done that in one of the papers I've written and some of the stuff that's now online. And now I'm at the point of simulating, and there's some really advanced simulation tools. And then from there, experiments based upon all of this. So that's the process I'm taking, um, but that's where we are. So the key point of it was this complex material, and what I mean by complex is one that has a imaginary and a real part, and that's what this dielectric needed to be. And now I fill this chamber with this dielectric material, so now everything inside is living under that condition. So then my point is going to be introducing a RF waveform, electromagnetic. RF stands for radio frequency waveform, into that material with enough energy that it will focus the RF signal, the waveform, the energy down to a point where perhaps it can then distort space time somewhere in the center of that chamber.
Okay.
Now,
So
yeah.
let me translating a little bit, or just trying to
Hmm.
get to that a little bit. So you've got a chamber. What kind of material is it? It's a gas, correct? Or
Actually, it's a liquid, and believe it
a
or not,
liquid?
it's a pretty simple liquid that
What
we've
what
all very familiar with.
might I ask?
It's called ethylene glycol, but most of us know it as antifreeze.
Okay, so taking the antifreeze out of my car, you put it in this thing, which is, you know, we're in the winter, so but anyway, I'll
Yeah.
let you have it. And so you've got this ethylene glycol, and now you're getting ready to aim RF, which is basically radio waves,
Hmm.
at it in a focused way to make something happen, right? So that's
Into
where
the
we are.
chamber. Yes.
Okay, go ahead.
All right. So now, how do we know if something happens? That's the other part of this measurement. The measurement side of it is a part of this experiment now. And what we would need to do is measure very, very sensitive changes, because from my, back of the envelope calculations, you need an enormous amount of energy just to get a little bit distortion to happen. So how do I measure a little bit of
Mm-hmm.
distortion? Well, there's something called an interferometer, and what some of you may know or have heard about this is that they're using it to measure gravity waves right now. LIGO is the acronym, but it is basically a laser that interferes with itself. A light beam is a wave, so you can see interference patterns as a result. But it's a, fairly, it's not very complex setup, but it's one that a laser goes through a splitter, it splits into two, then you bounce them off of mirrors and have them recombine at a screen. And when they recombine and you set the conditions just right, you'll see these fringes on the screen. Now, these fringes are on the order of the wavelength of the light. And the laser that I'm using is about 532 nanometers, which is really, really, really small. 10 to the minus 9 is nano. So smaller than a micrometer, smaller than a millimeter, really tiny.
Mm-hmm.
So if there is movement at all, I should be able to detect that movement if it's on the order of a few nanometers. If it's bigger than that, that's great. But even if it's small as a few nanometers movement, then I would be able to detect it, because I'm going to put my device down in the center of that beam. And then
Mm-hmm.
I'm pumping it with the RF, as I mentioned. If there is some change, because the beam will be going through the center of the chamber, if there's some change in the space time, that you'll see the fringes react. That's the
So let me ask you
experiment.
this. I'm going to
Hmm.
show my ignorance here. So you're splitting the laser. Now, is
Hmm.
one part of that a control,
Yes,
and the other
yes,
is going to go through the system,
yeah,
right? So you're
that's
splitting
right.
the laser in two.
Hmm.
One of them is just the normal laser doing its normal laser thing. And then the other one is what you're sending into your experiment. And then
Hmm.
they recombine.
Hmm.
And then there's maybe some haze or blur or whatever around the edges, or maybe that's
No,
not the right word for it. What is it?
well, it's
There's
called
some
interference. They're
an
going to
interference.
interfere
There's
with
some
each other.
cancellation going
Yeah,
on
they
or
can't.
something.
That's right. They cancel each other out at certain places. In the places where they cancel each other out, you see dark rings, and where they
Got it.
add together, you see bright rings.
Right. And that tells you that the laser that's gone through the experimental medium, something's happening.
No, no, not yet.
Okay, help me out. Go ahead.
Because if you have no device in there at all, you'll still see the interference fringes.
Okay,
Now, what I'm looking for is, so everything being equal, you'll just see stable picture of fringes on the screen.
got it.
Now, if I begin pumping this RF chamber and I'm going to pulse it so that I know what I'm doing versus what basically you could be shaking the table and see changes. But
Hmm.
I'm going to pulse it at a regular rhythm so I know that if there are changes and I see those changes in the fringes pulse at the same rate of my RF, then I know I'm doing it.
Okay, there you go.
So you
Okay.
want to look for changes in the fringes. Now, the setup I have has a little knob on it that you can change the position of the mirror ever so slightly back and forth. And if you do that, you're changing the length and you'll see the fringes move. So
Hmm.
now if that's fixed, the only other thing that will change effective distances will be my device if it is indeed changing space-time dimensions. And
Wow.
that's what I'm going to be looking for.
Okay, my head just exploded.
And
Um,
let me say something
yeah,
else,
keep
because
going. Keep
this is
going, man.
very important.
This
This
is good
part is
stuff.
very important, because what happens most of the time when people talk about this and they start saying we want to travel faster than light, they think about a starship going through space. Now, in the lab, I don't want anything moving faster than light because I can't see it. I can't measure it. I can't,
Hmm.
so I want to just see if I can get a little bit of a distortion. So the equations for the energy, the amount of energy is tied directly to the velocity that you want to travel at squared. So think about how big of a number that is. If I want to
Yeah.
go 2 or 3 times the speed of light, you take that number, which is 3 times 10 to the eighth meters per second, and square that. That becomes 9 times 10 to the 16th. That impacts the energy. But guess what? I don't want to go that fast. So I can go
Mhm.
really, really, really slow. I just want to see the distortion happen. So
Right.
that means that the energy requirement will not be as great as for somebody who wants to go, multiple times the speed of light. And this, I just want to be the first to experimentally verify that you can distort space-time artificially in the
Right.
lab.
So what you're looking at, and people who've been following the news just heard this whole thing about fusion. And so
Yeah,
what you're looking at is like you're not going from experiment to, hey, I'm going to power your house.
yeah,
You are just looking for the most minute possible indication
yes,
that you are on the right track. Just like the tiniest tiny, in your case, like beyond tiny, right?
right.
As is the case with the nuclear, right? Or the fusion. So all you're looking for is just the indication you're on the right track. You're
That's
not,
right.
yeah, you're not, boom, you're not going
Yeah, I'm
across
not
the
trying to
galaxy.
build a starship yet, but
Right,
once
right,
you
right.
do that, then okay, now I could actually begin to develop a relationship between the input power and how much distortion I can create. And now you can scale it. You could begin to scale it to say, all right, well, I need a chamber that's as big as houses ship. This is how
Hmm.
much power I'm going to need to actually make it move at any given speed. It's interesting that you bring up fusion. I'm working with a gentleman out of Atlanta. You talked. As a matter of fact, he was on the panel with me. A guy named Greg Hodgkin. What he's
Hmm.
trying to, what he's postulated with his group is that space-time distortion can help to enable stable fusion reaction by bringing the atoms, the molecules and the atoms closer together, the elements of the atom closer together. So now when you can achieve fusion more easily and more a stable situation. So he's chasing that down, but an enabling technology would be if you could indeed distort space-time in a specified way. That's what. So we've been talking. He has some proposals out. He's raising some money on his end to do it. But it's an interesting prospect, and you could imagine other things. Now think about it. People always talk about okay, traveling around the speed of light, but what if we were just traveling around at, you know, 1% of the speed of light? That's way faster than anything we've ever done. And just suppose that our propulsion systems were based on this now, as opposed to rocket fuel, and other types of things, just to get back and forth, even around our own planet.
Yeah.
Or getting to the moon in minutes as opposed to days and or hours, and getting to Mars in weeks as opposed to months, and you know, so we don't have to go full 10 times the speed of light and start heading to Alpha Centauri, you know. But every technology has a basis, and then you start building on it as time goes by.
Right, right, right. So walk before you run. And
Hmm.
so look, this is incredible stuff. My mind is just blowing moment by moment here, as I'm sure some of the listeners are. Um, so we're going to come back. We're going to take a little break. We're going to come back and talk about a couple other things here. I want to wrap this part up when we come back, and then get into some other stuff you're doing or have done. Ladies and gentlemen, all right, welcome back. I have Dr. Chance Glenn. We are talking about an incredible set of ideas that involve the ability to travel faster than light. And as Dr. Glenn was saying before the break, this means you could travel through the solar system in, days rather than months. Eventually getting up to the warp speed, Scotty moment. But it's incredible work. And where do you see this going? I kind of want to wrap up this idea and get on to some
Yeah.
other things. So,
Yeah.
where do you see this going next? What's how long, how far away is this?
Yeah. Well. First of all, let me say that just a quick input that uh, the way that Dr. Cubieri formulated his metric was that inside this bubble, quote unquote, the passengers would not feel the effects that go along with moving beyond the speed of light, time dilation, compression, all the other things that go along with it. Um, so that's a beautiful
Mm,
consequence of it, and perhaps not even the inertia of acceleration, because inside the bubble you're actually not moving. It is space time that is moving around you. So
okay.
all of the things that inertia, where you feel when you're being pulled back by acceleration, those things won't happen according to his formulation. So that's another interesting thing as well. Now you talked about when. Well, I'm in the midst of doing the analysis, doing the simulations, and developing the experiment. And I've gotten very well down the road in some of the first experiments, at least setting up some of the first experiments. So within weeks, I have some answers that I need to know. Now, the thing that is probably going to be the most critical is how much power will I need to see any type of response, and hopefully it's something within the realm of possibilities in this lab or even some other lab. I know Dr. White has offered to utilize his lab space. He's got some things I don't quite have here. And then there's others who can come along. And I love hearing from people. I've already gotten some, because this articles have gotten out. Some of the interviews I've done has started seeing itself on in the news and stuff like that. So I'm starting to get contacted by people, and some are interesting and some are not so much. But um, who knows what type of collaboration and relationships could be formed to do this, uh, if that happened. So I do invite people to reach out with their
Absolutely,
thoughts. Yeah.
absolutely. And so, one of the things you're going to hear is, "What about Einstein?"
Hmm.
Einstein said you can't go faster than light.
Yeah.
You're not really doing that, but
You're not
can you
really.
explain
You're
that for
not.
just a minute?
Yeah. You're not violating the cosmic speed limit. And some people actually questioning that too, but I won't get into all of that. But you're not violating that notion because you're actually not moving. It is space time moving around you. And there's already been um, verification that space time can move faster than light. That's connected to what people have done around the Big Bang theory and all of that. Basically saying that space time itself is moving and expanding at speeds far in excess of the speed of light. So space time can move. It's just that the real objects within it cannot move beyond the speed of light. So therefore, um, and then another thing is, what is not clearly understood is what it takes to open wormholes and things like that, where you're basically splitting space time or opening up uh, uh, sections of space time. It's not really known about that. I mean, they know, again, high gravitational, high mass objects can do that, where it collapses upon itself, and black holes we know black holes exist because we've now observed them. So all these things that Einstein postulated about bending space-time have been verified in reality.
Mm-hmm.
So my point is, at small levels, perhaps we can do some of these things ourselves.
That's great. So you are obviously embarking on some very leading edge stuff here. Um, I guess my last question before we leave this:
Mm.
are you finding, because science is about replication, are you
Hmm.
finding people that are able to replicate your work or build on it, or finding conclusions that align with the stuff you're coming up with in different parts of the world?
I'm not at that point because to me, I think the experimental verification is the real thing. I mean, there are
Mm-hmm.
people could look at the paper I put out and look at the mathematics. It's not really that complicated of mathematics, and it either is or it isn't, right?
Mm-hmm.
The mathematics works. Um, the question is, can you actually do some sort of measurable experiment to show that it indeed does what you say? And I'm yet to find that. Once I do and publish it, then I'm sure there'll be tons of people looking to replicate what I'm doing and verify what I'm doing. You can imagine the arguments and, you know,
Mm-hmm.
but I
Oh
say
yeah.
the proof is in the pudding. And
Mm-hmm.
if you can show that you actually are distorting space time, then it's just where do you go from there? How much more energy do you require to do something bigger or better or what have you? So, um,
So the next step for you is going to be to get something in the lab,
hmm
document everything you've done,
hmm
and then publish it out in the world.
yeah,
And then other scientists around the world, physicists,
yeah,
scientists, will either duplicate it or not be able to duplicate it.
yes.
And that's when the next level of fun begins, right?
That's when the
And
next level, because then it's about, okay, scaling and then applications therewith and
mm-hmm.
everything else you could do. And could you make something move as a result of doing it? And can you make it big enough to encompass something meaningful? And, what other things could you do if you could locally distort space time briefly or whatever? What else could you do? All of
Right.
that is going to be on the table. So I just want to get the basis and the fundamental piece down. And look, I'm not the only one working on this. As I mentioned, Dr. White, he's looking at it at a quantum level. I know there's a gentleman named Eric Lenz out in Washington State who's taken another tack. And I mentioned our friend Greg Hodgkin and his group, and he's got some people out of the University of Alabama, Huntsville, who are looking at some other ways to do this. And so I'm just taking a tack that I recognized and thought, hey, well, why don't we try that? And you know, that's where it is.
Yeah, and
But
that's it. Go ahead. I'm sorry. Go ahead.
well, I was just going to say that this is just one of those kind of feelings that things are falling into place right correctly. It just kind of feels a little bit like that.
Mm-hmm.
But you never know. And look, I'm going to do the experiments. I'm going to take my results. I'm going to publish what I see, and then let the world decide. I mean, I may find that there is no effect, at least for what I'm able to do, and you know, we have to understand why not if it doesn't work. You know.
Right. Right. But here's the thing. You, coming from a very interesting background, have arrived at a place where you are challenging some of the basic tenets
Mm,
of physics and our understanding of our place in the universe.
yeah.
If you are successful, the universe opens up.
Yeah.
Like we're going big time, and that's one reason I'm very excited. But I am also intrigued by how you got to this place. I mean, you have
Mm,
a very interesting background, um, and you are kind of like that guy coming in from left field and going, here's the equation. I see your equation. Why don't you try this, right?
mm,
And I think it's partially because you have sort of a Renaissance mind, right?
mm,
You are the kind of person who doesn't limit your possibilities and
mm,
limit your ability to enter intellectual conversations or interactions on anything,
yeah.
right? That's who you are, and I want to hear a little bit about that. You had mentioned earlier when we were talking that
Mm,
you came from Southern Alabama, right?
Yeah, yeah.
Yeah.
Well,
Tell us a little about that. How you end up here?
all right. Well, and there's a tie into everything you asked. I'm gonna see if I can't get there.
Okay.
The first of all, I was born in Newark, New Jersey,
Okay.
around the time that there were, racial riots in the '60s, and our family and my father was a policeman, and he basically packed up all 8 of us kids, and we rode on the back of a U-Haul truck down to Alabama with our grandma to be with our grandmother, who was also not raising, but taking care of her aging father. So grandmother and a great grandparent, that all of us, and I was the youngest of 8 of us that grew up there. Now, so we didn't have a lot. We were basically in a cinder block house that was no bigger than this room that I'm in right now, and all of us piled up in there, and that's how we grew up. Now we figured it out, and that was part of the what I'm talking about. It's just that almost making a way out of no way, as some people say. Whether it was the toys we played with, the things we did, we had to come up with it. We had to create it. So I think that creative aspect was there. Then the the point about not giving up was built into it, because if you wanted to have something, you had to figure it out and you had to come up with it yourself.
Mm-hmm.
That's how it worked for us. And then finally, and this is an aspect that is very important. It sounds simple, but it's very important, and that is courage, or what I should say, lack of fear. So not fear of not trying things, fear of not making that next step, fear of not walking through that door, fear of not asking this person this question, or even putting yourself in a certain situation. Fear can keep you from a lot of opportunities,
Mm-hmm.
and that is one of the things I think that is a distinctive about me. So I like to just try everything, and I'm not afraid to try. I'm not afraid to fail. I'm not afraid for people to say, "Oh, what were you doing? That's ridiculous." I just try it, and if it works, it works. And so that's a powerful part of all the other skill sets and abilities and talents and stuff that you have. Fear is the number one dream killer. And so if you just get to the point where you say, I don't care whether I fail or not, I'm going to try it.
Mm-hmm.
That creates a lot of opportunity for you.
Yeah, and you're not saying you're not saying don't have fear, because we all have fear.
Yeah.
It's how you take it,
Manage it.
how manage it, how you
Yeah.
deal with it, where you put it.
Yeah.
Right? It's like
Yeah. Yeah.
I got the
Fear.
fear. I'm going to put it over here, out of my
Yeah.
way.
Well, fear is important. I mean, that's a protection mechanism. It keeps us from doing stupid things and getting ourselves killed and
Yeah.
all that, or danger and all that. I mean, that's what fear is for. So it's a necessary thing, but it can also keep you from doing what you are supposed to, or what you're meant to, or whatever your abilities may allow you to. It can keep you from experiencing something that you need to experience. Even failure, which I mean, failure is the number one teacher. You don't really learn something from succeeding. You learn a lot more from failing. You learn what not to do. And I've failed a lot of times, so I'm not afraid to say
Oh
it.
yeah, me too.
But you learn something, and if you can apply those lessons, but you never will learn that if you're afraid to fail, and therefore you never try.
Perfect. We're going to wrap this section up with that. My name is Rick Tumlinson. You are listening to the Space Revolution right here on iRock Space Radio. We are a part of the iHeartRadio network, and we are talking to Dr. Chance Glenn. Not a man who has no fear, a man who has had fear and just put it out of his way. All right, my wonderful spacers, we are back. The last segment here with Dr. Chance Glenn. We have broken all the laws of physics. No, we didn't really. We didn't break them. We just went around them. Just went around them, officer. You don't have to pull us over for breaking the speed limit. But some incredible work on going faster than we have ever thought before, and it's very inspirational, and I love it. And speaking of that, one of the things you do, Dr. Glenn, is the Morning Bird Foundation.
Hmm.
Tell us just a little bit about that, because I feel your energy, and I gather that you have a way of transmitting that energy to students and young people.
Yeah.
Tell us about Morning Bird.
Well, I've done a lot of things, seen a lot of things, been a lot of places. Sounds like a song, right? I first of all, I consider the Morning Bird Foundation as my fountain of good works. It's a place where I want to just do good things for others, and from this basis of whatever I've been blessed with skills I have, and try to share that. I mean, clearly my background is in the sciences, science, technology, engineering, and math, which is the STEM acronym we talk about. Well, the Morning Bird Foundation's major mission is to provide opportunities for STEM education, to particularly to underrepresented and underserved communities. And
Mm.
the reason why, and I have this, it's picture of diversity. And interesting, back in Star Trek, I know they started this Mr. Spock, who's my main guy. That's my guy. I patterned myself. But he had this thing called infinite diversity and infinite combinations. I know they tried to introduce that. But what that meant to me is that diversity is a powerful thing, and it is a beneficial thing that we should be leveraging as a society and not vilifying, and not even tolerating, and not just barely accepting, but we should be leveraging and celebrating diversity in all of its aspects. And diversity means there's diversity of thought, there's new ways to come at a problem, just like what we've been talking about. Just because of the background I've had and the experiences I've had, I looked at the same problem that others were looking at from a different way. And
Right.
that's the benefit of diversity. And you don't know what kind of brilliant minds live in all different situations, and we need to uh, 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 not only cultivate that, but also benefit from it and cherish it. So that's why I believe in diversity and giving as many people as possible an opportunity to operate in this space of STEM and all that. So the things we do there, we do training in things like 3D printing and robotics and coding, and then do research, which is the basis of some of like what I've been talking about. And I've not only done this research, but others in additive manufacturing, materials, 3D printing, and stuff like that. And then it's also advocacy and scholarships. We award scholarships, and we've been doing that over the past year or so, to scholarship deserving students in college, and we've done it for universities and students all over the country. So all of that is a mission that is driven from the core of who I am. And so the resources I develop, I mentioned I work with SpaceX, where they, as a consultant, where they support me in that way, and I use those resources to help develop the foundation and do what I just talked about. Now, of course, we need help, so people can go and visit us at morningbirdfoundation.org, and support us in any way that you can to do the things that we're doing, including this research I'm talking about. Um, and there's a nice song, and you're free to use it if you want to, because I'm a songwriter and singer and all that other stuff. There's a song there called Can You Imagine that you will get for free to download if you support us. But the song is also available on Spotify and Apple Music and all those other places. So look it up. But it talks about that notion I just mentioned, because could you imagine what our world would be like if we worked together, leveraged all of the value and the beautiful combinations that we have on this planet if we actually use that to build a better society together. Imagine what kind of world we could actually have. And that's what the song is about, but that's also what the mission of the foundation, and that's what that's all about as well.
It's a beautiful vision. Beautiful vision. We obviously simpatico on that one for sure.
Mm.
So, all right, I have to ask you the heavy questions because it's
All
just
right.
a tradition I have here, and these are hardcore questions. So,
Yeah.
um, the first one, I guess, because we just chatted, hit a music moment there.
Mm-hmm.
Let's say you were, in your case, you're not flying over the moon. You're flying out into the solar system. You're on your way to Titan, let's say,
Mm-hmm.
because you're using your drive,
Yeah.
right? So flying over the moon would just be, you'd be done, right?
Right.
Gone.
Right.
It's too
Right.
fast for this question. So you're cruising on your way out to Titan. You can see the solar system around you. What would you be listening to?
Oh wow. I'm a jazz guy, probably at the core, and not and more of the smooth. I have rhythms in my head, and it's always like that. I'm always got some sort of song going on in the back of my head, or rhythm or beat or something. And so it probably would be that. As we pick up speed, though, it might be a little bit of heavy metal
I
thrown in
like that
there.
transition. So like
Yeah,
we're going for like Bob James, Earl Clue to
yeah,
something hardcore, huh?
yeah,
I
a little
like it.
bit hardcore. I mean, I'm not all into the different groups. I just know the sounds, and so I'm
Yeah.
just about the sounds and the moment, and But I listen to all kinds of stuff. I mean, I've written and performed gospel stuff primarily, but I think at the core and foundation, jazz, classical is something that will be in there as well as I kind of settle down.
Yeah.
You know.
Just enjoying it all. Enjoying it all.
Yeah,
Sampling
yeah,
of humanity.
absolutely.
All right. Cool, cool. And who was your most inspirational if it was science fiction writer or book, either way, that you've read when you were young?
Well, I remember reading The Green Hills of Earth by Heinlein. I also
Mm.
read The High Frontier. Yeah, The High Frontier.
Oh yeah.
Um, as again, but I've read all of the Star Trek novels because that's just my jam. That's my thing. And anything that Mr. Spock, because he's a cool customer. He's the coolest man in the room. He's the smartest man in the room. He's always got to figure it out, and he doesn't play. And like I said, I've worked on my personality sometimes just to almost have that because he's got layers to him. It's not just he doesn't have any emotions because he does. He just suppresses them and only allows it come out when it's really 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 important. And you know and that's my guy. So everything, I've read a lot of tons of those novels, and that's another thing. And I've read some things on Einstein's life that
Hmm.
really getting behind all the mathematics and science and everything that the physics that he developed, and who he was as a person, is another thing. And of course, a personal hero has to be Dr. King, just because of what he did for this society. And I think he showed us a better way, a way that did not bring about conflict, in a way that now he showed the ugliness of humanity, but he responded with peace and love. And that's what taught us a better way. And I believe that was a salvation for our society at that moment. So to do that again goes back to what I was talking about earlier, and that's that courage. It takes
Hmm.
courage to do something like that.
Wow, you had just proven you're a Renaissance guy because you went from. And by the way, you checked my boxes,
Mm,
So you had Heinlein, my old boss, Dr.
yeah.
O'Neill, in the High Frontier. You have
Mm,
Spock,
yeah.
Roddenberry.
Yeah.
Wow, Einstein. and then King. That's a good
Yeah,
lineup. I like that. I can
yeah,
dig
it's
that.
like a well-rounded
Yeah, absolutely,
space there at
absolutely,
the time.
and I love it because you're bringing it all together here today. So, I guess the last question on that, the serious section there would be, what's your famous science fiction TV show or movie? I think we already nailed it. I
Yeah,
think I kind of have a
yeah,
slight hint
yeah,
here
yeah.
that we
Of
kind of
course,
might know what that is, right?
yeah,
So,
of course. I
Star
mean,
Wars. No, I'm kidding.
no, boy, don't do that. No, no, no. And there's a reason why Star Trek, and it isn't just the technology and the stuff. It was what the picture of the future that they painted at the time that they did it. Now,
Hmm.
you know, this was in the 60s, as I mentioned, it's tumultuous time. As a matter of fact, that it was started on the year of my birth, which is also interesting. But in the 60s, yet on the bridge command crew, you saw a black woman, you saw a Asian, or I guess he's Japanese, navigator. You saw a Russian. You saw a Scottish engineer, an alien first officer, all working together, and they never really even mentioned it. That's the part that was. In the times I remember
Mm-hmm.
when Uhura took the navigator position, or when she worked on this, the communication system, and basically implies she was an engineer. They never said, "Oh, it's great to see you doing this." They never said. They just did it, and things like that were very inspirational to see that this is a possible future
Mm-hmm.
where people could have adventures together. That's what struck me, and you don't really see that in any of the other things of the time. And so that's what struck me. And then all the other stuff, the techno stuff, was just gravy. So, and
Absolutely.
I'm still inspired by it. And I like when I see the newer stuff harken back to that earliest um, philosophy that was developed by Roddenberry and those creators around
Yeah, and it's exactly, and I resonate with that. With my Earthlight Foundation, we have our principles, and
him. Yeah.
the second one is called to honor and evolve human civilization, and
Mm,
and that's very important because we honor where you come from, who you are, what your perspective is, and
yeah.
together we evolve into that sort of that seamless. We are one humanity
Yeah.
approach to the universe, or
Yeah.
one, in Star Trek's case, one sentience,
Mm,
because we have all the beings from all the different
hmm.
species all
Yeah.
coming together,
Yeah.
because
Yeah.
that's the source of wonder, is these minds that can go out into these beautiful places and explore and experience them together, right?
Yeah.
And that's what we're all about.
And
So,
we've got to speak to the strength of that. We have to make sure that people understand it's a powerful position, not a weak position to come from.
tell me a little more about that. What are your thoughts on that?
Well,
It's just, let's wrap up the show here. I want
yeah,
to I
sure.
want to hear you lay that out as to where we are right now, which is a very tense and dangerous time. How do
Geez,
we get there?
thanks for asking that, because I do have a thought about that. Because what has happened is that with terms like political correctness and snowflake and things where you know certain elements want to take what is beautiful, what is something that allows us to consider all people and their positions and the way they feel about things and all that, and turn it into some sort of weakness. That but here's the thing, it takes a lot of courage to be thoughtful, to show mercy and compassion, to not react with violence and anger when you could. Those That takes courage to not do those things.
Mm,
So we need to almost turn this thing around where it's not think about some of the greatest people in our society. In philosophy or whatever religion would have you, even go to Jesus Christ, to Martin Luther King, I mentioned Gandhi. Those people who the amount of courage it took to do those things um, was greater than it would have been to just say, let me pick up a sword or a gun and just go at it. So
Mm.
we have to understand there's courage and strength in being considerate and thinking about other people. And that's a message. But and another message that, since we're talking about space, and the space industry, space economy and all that, first of all, there's only about 60 or 70 people who have ever gone into space in the history of mankind.
Mm-hmm.
And um, beyond our, our borders, of the Kármán line, I should say. But my point is this: the blessings of the space economy, the all of these players that are now getting into it. It is important that those benefits that come from space exploration are made to benefit all humankind. And I'm going to be doing some things where I'm talking a lot more about that, because it's a message not just for the populace, it's a message to those people who are working in this industry to not get so caught up into your discoveries and the money that you're going to make by putting hotels in space and sending people up in balloons and hotels on the moon, and for people that can do it. But how do those things benefit all of humanity? Because if you do that, and if you communicate it well enough, you can get the support of humanity.
Right.
Because
Absolutely.
Neil deGrasse Tyson is a guy I listen to sometimes, and he made a point that the money that we are talking about, or the resources we're talking about to terraform Mars,
Mm-hmm.
we could terraform Earth and create fix climate change and everything else that's impacting our society. So, people are going to say, well, why are we doing all this out there when we could do what we need to do here? But the point is that what we do out there should benefit all of humanity. And that way
Mm-hmm.
we can communicate it better. And that's the point I'm trying to make.
Yes, absolutely. We save the mother world, and then we go. We carry her out, carry her seeds wherever we're
But
going to
we
go.
communicate why it's beneficial to do that to everyone.
Exactly.
And that way you can get the
Exactly.
support.
Yeah, it's not either or; it's both and.
It's yes,
All right.
absolutely.
So, all right, sir. Amazing, wonderful conversation. We have literally traversed the universe in and out of culture and space and time, and broken no laws of physics while doing it.
At least that we know of.
Yes. Had we broken any laws of physics, you would be notified by. All right. Thank you so much. All right, spacers, thank you for tuning in. This is iRock Space Radio. You have been listening to the Space Revolution. My name is Rick Tumlinson. Our guest has been Dr. Chance Glenn. Tell your friends we are out the airlock.